Soil is the most species-dense habitat we have on Earth. There's more bacteria in just a spoon of soil than there's humans on Earth. And it's also the by far most important carbon storage we have. In soils, there's more carbon than in all the living biomass and in the atmosphere put together.
Unfortunately, climate change is also affecting the Earth's ability to store atmospheric carbon dioxide as carbon in the ground.
And in times of climate change, it's really important to understand that big carbon storage much better, because small changes in the carbon balance of the soils can make a huge feedback to the atmosphere. And there are approaches that want to increase carbon sequestration to soils, and that is of course very promising. But even more important is that the soils are also a very important contributor to CO2 emissions because of changed land use, and they are huge sources of CO2 in very many ecosystems.
It's a balancing act. We need the soil for cultivation and for storing atmospheric carbon dioxide. For instance, ploughing the soil increases nutrient availability and gives short-term benefits for good harvests. At the same time, it disrupts carbon storage and impacts on the climate. But in what way is the storage capacity of the soil affected? It's hard to get a picture of the soil's structure at the micro level, and there are many parameters that affect carbon storage. So, the researchers are designing microchips, small models that copy the soil's structure with all its passages and cavities. This enables them to investigate one or a few parameters at a time.
For each experiment, for each research question we start with drawing a spatial design on the computer that helps us to answer that question. Then we go into the clean room and produce a master, which is kind of a stamp, to be able to construct the soil chips from. And then we use this master to pour a two-component polymer over to harden it, then take it off from there. We bond it in a plasma oven covalently to a glass slide, and this is then the final product. We can inoculate them with different microbial cultures or with soil sample to get the whole community in. And then all these organisms, they're very happy to colonize the spaces. They just grow and swim into the chips.
Many of the soil's inhabitants are good at breaking down and distributing organic matter in the soil. Edith Hammer and her team of researchers are focused on the really small decomposers, such as bacteria and fungi, and their enemies, the soil's predators, single-celled protists. But they don't eat everything. Much of the organic matter is left behind, contributing to the storage of carbon dioxide. One of the reasons for this seems to be the complicated structure of the soil.
The soil pore space is like a big labyrinth, and the food and the organisms that want to eat that food often don't get together, because the organic matter can be hidden deep into aggregates or being so difficult to reach that it takes more energy for the organisms to access than it's worth in the end for them to fight for that food. So that labyrinth system I sometimes compare to Pac-Man computer game, where the microorganisms need to find the food and also at the same time need to hide from predators that want to eat them at the same time. And so the more intricate that labyrinth system becomes, the more organic matter can accumulate. And that is the theory which has been very difficult to approach before.
The researchers are studying how different conditions affect the organisms. For example, they use Raman spectroscopy to study changes to the chemical structure of the microbes, the soil, and the organic matter.
Each peak in the spectrum represents a certain molecular compound in a fungus. So, for example, this might seem like just a noisy curve, but for me, every of this peak means something, so you really have to adjust yourself to reading this, but once you do, it's actually really informative and really fun to do.
The analyses show that the metabolism varies in the organisms when the conditions change, and this affects how much they eat, which in turn affects how much organic matter there is to store carbon in the soil.
Soil gets way too little attention for biodiversity conservation and for ecosystem conservation. I think recently also politics, global politics are getting more aware that we are having this super important resource which our societies are based upon and we're not taking care of them properly. We're treating soil as dirt, but soil is the base of our society for food production and a lot of our culture.